Good morning, fancy meat computers. How is your life going? I hope that you guys aren't all dead. Death is usual this time of the semester. It's crunch week before the break. I hope that you all go out and buy some Doritos and some Cheetos chips so that you can have a good crunch week. Ha! Because they crunch when you eat them. Terrible joke. Terrible joke. How is everybody today? I hope you're good. I hope you guys are doing well. Let's see, we got 12 people concurrently viewing. Think Lambda. Oh ho, somebody's been watching my other streams. Yes. Think Lambda, indeed. Haha. Dead. Pranked. Wah. There we go. Yeah, I expect that the viewership will probably be somewhat lower this week. So only the most dedicated of students will show up to class this week because of all of the everything. Too many midterms, too much work. But look forward into the future to that sweet, sweet break week that you'll be having, in theory. Although, you know, some professors might be madly scrambling to get you assignment 2 so that you can work on that over the break at your leisure. But, yep. That's kind of how it goes. You know, there is a lot of work, but, you know, it's kind of like, it's not like there's any less work when you get out into the real work, you know, the world of work as it exists. It's not like your burden gets any lighter as you go on through life. Your burden just keeps getting heavier. This is like one of the terrible hard truths that I learned about undergraduate. Is it's like things are shit, but get used to it, because you're about to enter, like, in a few short years you'll be in the actual real world where the consequences of making a mistake are much greater than getting a bad mark on an assignment. So yeah, but it's also a decreased probability that you'll be required to do dedicate at like high level mathematics. But anyway, I am procrastinating on homework this way. Ha! Yeah. Oh yeah, this is the procrastination class. It's pretty terrible when you're procrastinating by going to class. It's terrible. Reading week won't be a break. It's just time without classes to do a lot of assignments. Yeah. Us dedicated students should get some compensation, don't you think? Perhaps a few extra percentages on your assignments. No. It would be I don't do attendance marks because I can't be bothered. There you go. That's it. I can't be bothered seeing which one of you is here and which one of you isn't. It's just too much for me to have to care about. The class has like 100 people in it, so yeah. Also, I kind of feel like if I were to do something like that, I would be like violating this pact that exists between university professors and their students, which is like, you guys get to not show up, and then I get to not care that you don't show up. And that's our pact. I'm fine as long as there aren't like 3 people in the class, because then it just gets a little depressing teaching to 3 people. Don't be bothered. I mean, did you guys find assignment 1 that bad that you guys need bonus marks on it? I thought it was pretty easy. But, I also thought the assignments I'm giving my third-year class were pretty easy in there. Like, somebody did a cartoon of people, like, drowning under icebergs as a metaphor for their feelings about these assignments that I'm giving them. So, what the heck do I know about it? Anyway. So, might as well get on with it. Get in, get around. Arrays. We're going to talk about arrays today. We're going to talk about data structures. We're also going to talk about some rudimentary algorithms, because we have acquired enough C to be able to talk about some rudimentary algorithms. So those of you who are big programming buffs, you'll probably find this to be... you'll probably know a lot of this stuff already, but my theory is that you guys, as mechatronics students... You guys now have an algorithms course, which is good, but a little bit of introduction goes a long way. So, I had more trouble with uploading the actual assignment than doing it, lol. Yep, that's, Git is a very useful and important skill. If you're going to work in a company that uses software, you're going to be expected to know how to use a Git repo. Or, whatever the competitor is, like SVN, but they all work pretty much the same way, just they've relabeled the functions. But yeah, better to learn it now when it's not like, oh, this guy's an idiot that I just hired, So, not that, you're an idiot because you don't know how to use Git. It's more like you want to get onto the job with, like, what the employer considers to be, like, the rudimentary skills of your profession. Yeah. Had trouble figuring out how to type what you wanted in C without it having a hissy fit and causing an error. Yes! Yeah. Yeah, the C compiler is a little bit more temperamental, shall we say, than Python's. And, you know, part of the whole reason that, like, algorithmically speaking, assignment 1 is not... It's not the sharpest crayon in the box, let's just say, with respect to difficulty levels of assignments, is because you guys are, like, getting used to the syntax and getting used to how C programs are compiled. So, you know, practice makes perfect. This code is like speaking to a grammar Nazi. Yes. Yep. It's not as bad as the grammar fixer bot that they've put into the school email, though. You want real grammar Nazis? That is electronic Hitler right there. Or maybe just Himmler. Maybe there's a worse one out there. I don't know. Was Himmler worse than Hitler? Who knows? Anyway. So let's talk about arrays. I think I did these first 2 slides last week, but whatever, I'll do them again. In Python, there are many data structures to choose from. You have tuples, lists, dictionaries, sets, and strings, and those are just the ones that it comes with by default. In Python, you have the ability to build your own data structures, so long as you're willing to make a class for them and support the requisite magic methods. In C, the only data structure that is natively supported is the array. If you need something more complex than an array, you either have to find a library defining it or define it yourself. But that's fine, because if you take a look at all of these things in Python, all of them, every single one of them, is just an array with special means of access or properties. So they apply, you know, X property, Y property, Z property. You get these different types of data structures. But the primitive one, from which all of them are derived, is the C array. Because you may not know this about Python. I actually just found this out over the weekend. The Python interpreter is written in C. And a bit of Python, but mostly C. So, what is an array? An array is a contiguous segment of memory, which may be accessed via linear indexing. The word contiguous means that it is in continuous memory. Contiguous means, like, it's a geometric term that also means that they're, like, each memory cell is physically adjacent. So, all elements of an array have the same type. So, unlike your tuples or your lists in Python, which may be polytyped, in C, arrays are monotyped. Arrays use 0 indexing, and arrays are static in terms of size. The size of an array does not change during execution. This means that the size of the array must be known at the time of declaration. If you're using arrays just as arrays, this is totally true. You can get around this using pointers and dynamic memory allocation, but you're probably tired of hearing me talk about pointers without us actually talking about pointers, so we'll just leave that for, like, after the break. Is it done as an array class in Python, since it's an object-oriented programming language, or do they give some different attributes based on something else? PK, I'm not quite sure what you're referring to there. Are you talking about, like, the data structures in Python, or are you talking about arrays in C or arrays in Python? I'm not sure what you're talking about. So, syntax, my friends! An array is declared in the following manner. Int So you declare the data type, in this case integer. You then declare a name for the array, which can be any identifier that's a legal variable name in C, and then square braces, and you put a number x, which must be either an integer literal or an expression evaluating to an integer literal, or not a literal, an expression evaluating to an integer. So you have to provide this because that tells C how big the array is. Remember that in C, arrays are statically sized. So you must know how big the array is on declaration. The data types in Python. Gotcha. No, it's, I don't know. Python might have an array class. It probably has an array class, but it's more like this is the layer that's going on under the hood, right? This is what you would consider your primitive. Arrays are the primitive. You don't need to know how to code. You'll just Google your way to victory in real time. I mean, to a certain extent, that's true. But you do sooner or later have to know what you're talking about. If only in an interview, you'll need to know what you're talking about. So, note that x must be, yes, this rule applies to array indexing as well as declaration. Yeah, so you're allowed to put an expression in here, if you didn't know that already. But whatever the index you're using on an array, or whatever you're declaring with, it must be an integer. Aren't lists in Python basically progressive arrays? I don't know what you mean by the term progressive in this context, but sort of. The closest thing in Python, I will agree that the closest thing in Python to a C array is a list. But in Python, lists are not monotyped. So, on declaration, an array is filled with junk data, smelly, smelly garbage. Arrays may be indexed using the array index operator. You can assign to the elements of an array. You can read from, like, you've got read and write privileges on the cells of an array, which is in contrast to Python's tuple, where you don't have write privileges. Binds at the same level as function calls, so very tightly. And, this guy binds more tightly than any arithmetic operation. And as we'll see later, the index operator is syntactic sugar for some pointer operations. So, question. Could you, quote, change the size of the array by just defining one that's one bigger and then feeding the old array back into it? Yes, you could do that. But if you're starting to perform that level of manipulation, you would probably it's much easier to use dynamic memory allocation, because there's a function called realloc, which reallocates the memory assigned to a pointer. So you could expand or shrink or expand the allocated memory based on a single parameter given to a function, which is a lot easier than, like, it'll do all of the copying over for you if that's necessary. So a static array means you can't append to it like in Python. That's correct. That is, yes, thank you. That is very much an important point. In Python, appending is like fairly basic operation on data structures. You append a fair amount because, it's useful to be able to think of problems in terms of appending to arrays, appending to lists and stuff like that. But in C, it's static, therefore there's no append operation. You can get there with dynamic memory allocation, but again, we're not quite there yet. Like, right now, we're just talking about static arrays. So, pretty printing arrays. Let's let's pull up a topic 4.c. This is topic 5. There we go. If I ever make a mistake typing, I'm just gonna blame it on my new fancy keyboard. So include stdio.h int main. Oh my god. So int c 6 plus 6 float bar. I suppose it should be foo and bar, shouldn't it? 0.1, 0.2, 0.3. So these are a couple of different ways of initializing an array. The first one is uninitialized, right? Foo is not initialized and is therefore filled with smelly junk data. Bar is initialized. And you'll notice that this guy, when I'm declaring this as an array using the square braces, it's the presence of the square braces that distinguishes bar as an array. Without the braces, C would just consider it to be a float variable. It wouldn't be an array. And you don't need to include the number if you're initializing it in this fashion, because C is smart enough to pick up, 1, 2, 3, 4. There are 4 elements in this thing we're initializing it with, so the 4 goes in there. I can do that myself. You don't need to do that. That's what C says. So. The %p stands for pointer. It's going to be useful in a moment. And then there's no method for printing an array. So this is an interesting feature of C. In order to actually print one of these bad boys, it is upon you. It is your problem to actually write or use an array printing subroutine. I see I caught it out of the corner of my eye. I have a question or a comment. Close brace. New line. Oh, it's foo. There we go. There we go. All right, let's see how I did. Any issues? GCC. Topic 5. An issue. Warning. Yeah, that's expected. So basically, this is telling me that this guy is... I'm using foo as if it was an integer when it is in fact a pointer, but it still lets me get away with it. So... if you initialize an array like this, if it is int array 5, will it have 5 elements or 6 because of array 0? Good question. So let's It'll have 5 elements. I'll just tell you right now. Notice with foo, like 6 plus 6 is 12. Notice that we're looping up to 11, right? We're not including 12. So yeah. There we go. So you can see the first thing that we're printing is like the decimal value of the array itself. You'll see basically we're getting nonsense, but this isn't actual nonsense. This is what's called a pointer. So when you create an array, the name of the array, without, like, if you don't apply an index to it, that array is a pointer to the memory segment where the data is contained. And that's what's being displayed here. So, and just to illustrate the point that the array is filled with garbage data when you first create it, take a look at this, right? This is garbage data. This is about as garbagey garbage data as you could possibly want. And you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 elements. So we get 12 elements when we initialize the array to 12. Cool? What is junk data / smelly garbage? So from the perspective of like how the operating system manages data, we can take it from this perspective as well. So this is what happens, right? Your C program requests data. It asks the operating system, hello, operating system, hello, operator, please give me, 100 bytes of memory. I want to put an array there. The operating system is like, let me just check, let me see where I can find it. Here you are. There you go. You now have 100 bytes of data. The operating system does not wipe the data first, right? That data is previous, like it's uninitialized memory. The operating system doesn't wipe it before it gives it to you. Now there are ways of wiping, like using dynamic memory allocation. You can get like versions of it that do wipe the data before it gives it to you. But the reason that it doesn't wipe the data before it gives it to you is because, first of all, it's not always useful to wipe the data. Like if you are initializing the values to like non-zero values, right? The operating system would probably just wipe it to 0. So unless you also wanted it wiped to 0, you're wasting cycles, right? You're wasting operations because you're just going to initialize it to something else anyway. So yeah, the operating system gives it to you, like whatever happened to be in that chunk of memory, which is, most of the time probably going to be like instructions from a different program or memory that was used by a different program. Most of the time it'll be one of those things. Even if even if this is like the first program you ran since you started up your operating system. Remember, your operating system takes a certain amount of your RAM as well. Yeah, it just gives it to you because that's fastest, right? It's like, okay, you want 100 bytes. Okay, here's your 100 bytes. There you go. On to the next one. Because speed is like optimizing for speed at the level of the operating system is super, super important. How does C decide what values to throw inside the array? Like, why are some shorter or longer? Again, it's not, C didn't decide to give this to us. The operating system decided to give this to us, and it didn't decide to give this to us. It's just this happens to be what the previous values that those chunks of memory was used for. You know, this just happens to be what the memory contained previously to it being given to us. Right? And some are longer and some are shorter because, you know, some of this would be like object code, which is, you know, you don't need, you know, 64 or 32. You don't need 32 bits to store like a, you know, a machine code instruction for the average CPU. So you would store many of them in the single space, right? Some of these are negative because, like, we're interpreting these as signed integers, right? If you interpreted them as hexadecimals, that would, you know, also, you know, that would also work. But, you know, some of them are 0, some of them are long, some of them are short, some of them are negative. The point of showing you this is to sort of pound it into your skulls that you cannot rely on any of the values that an array is initialized with because it is filled on creation with smelly garbage. Yeah. So. So this is kind of like sort of what we would see if we were, you know, in blue Blockovision. I don't think that these are actually as useful as the demos, but anyway. So, compiler warning. In function main, warning, format D expects argument of type int, but argument 2 has type int star. So this... Oh, one more thing. One more thing that might be useful to show. Every time it's run, the garbage is different. See? It's different every time. Similar, though, but different. Actually, it's interesting. It's not as random as you think it is. Are those random junk data numbers always the same if you run that same code, or will they be different after you ran the same code like 3 hours later after doing other stuff? Yeah, it's different every single time because there's so much RAM, right? And you need so little of it. And the operating system doesn't give you the same memory cells each time. It gives you different memory cells all around the RAM, right? So it doesn't really matter. Yeah. So, yep. Just like with a lot of things in C, there are no free lunches. This is going to be my my motto for this class. There are no free lunches. You can't print a whole array just by passing the array's name to printf, as the array identifier is really a memory address or pointer. That's what. So you can't just take the array and give it to print the same way that you do in Python. That's not how it works, because this isn't an array. This is a pointer to memory cells, right? Although that is what an array is. To initialize an array, provide a comma-separated series of type-correct literals or expressions delimited with curly braces. That is to say, this is how you initialize it with non-junk data. If the initializer is smaller than the declared memory, C will backfill with zeros. If you initialize the array, you may omit the specifying the size. The size of the initializing array will be used. So here's a fun thing. If we make a very small modification, if we initialize this with, say, 0, 0, which is too small, right? This is not big enough to cover all of the elements in here. But let's take that and run it. You can see that that does initialize the array to all zeros. So in fact, you don't have to Let's see if it works with 1. It'll probably work with 1 as well. Yeah, there it goes. So that's a little trick, right? The trick here is when it's given an array that's underdetermined, it'll fill the rest of it with zeros if it's got a declared size here. So you can get an array of zeros, all of the zeros you want, by declaring a size, then making the first one 0, and it'll assume the rest of them are zeros, right? So that's how you can get away from the junk data problem. But it's, you know, it costs time to do this, and if you don't need it to do this, then don't, you know? Like, there's no point in initializing an array twice. That just wastes time. There you go. Macro man. It seems like kind of a pain to have to hard code our array sizes. There must be a better way. Define size 256. A macro is a preprocessor command which defines a character substitution that occurs prior to compilation. So, question. If you said 6 in braces, then it would be 60000. Yeah, it would be. But let's test that, because we test things, because we're scientists. There you go. Absolutely. Yes. So, let's see here what we're talking about. Yes, macros. So this is the simplest macro, is the define. I'm going to define size as being equal to 256. So if I then use the term size, it's a little bit like a type def, but if I put size in here, what happens is the preprocessor, one of the steps in preprocessing is it scans everything in here, looking for any of these define tags, and it'll swap it out for whatever it's being defined as. Can you initialize an array with a user input using scanf? Yes. Yeah, you could ask the user to give you a number and then initialize an array of that size. Yep, you could absolutely do that. You could also take it from argv, argc. You could also, you know, you could also declare an array based on the value of some arbitrary variable at some point in the program. You can do all of those things. The only thing is you can't modify the size of an array once it has been created. That's what you can't do. How is that define definition different from setting a variable? You can't write to it. It's simply character substitution. You can actually do some pretty interesting things with defines. You could do something like define triple close. They're typically capitalized. Triple close. There you go. And then you can replace, like, the thing about defines that make them different from variables is you can replace arbitrary syntax with them. Right? So let me just make sure that this is working. Yeah. There you go. Still works. Oh, except, let's see here. Did I save this? Oh, yeah, because I'm only... Oh, yeah. So here's the advantage of using size, right? Over here, I've had to write a loop where I've hard-coded the size of the array into this loop. But if I use, you know, this is like variables 101 in some sense. But if I use the size that's been defined, then, you know, now I actually do get the proper size of the I get, like, I can modify the size of the array in one place, and it happens throughout the file. It's a lot more like setting a constant, these defined statements, than it is anything else. So defined statements are different from variables because they can replace arbitrary syntax. So it's really most correct to think of them as straight character substitution operations over the entire file, right? You are substituting characters. You are not, like, just setting variables. Like, setting variables is almost like a brain-dead way of using them. Like, you can do very, very cool and interesting things with defined statements if you get clever with them. But, you know, they should always be used in the service of making the program easier to understand, not less easy to understand. So don't use your powers for evil, guys. But yeah, so that's what you can do with defined statements. Because, like, this guy, right? Triple, so at, like, during pre-processing, triple close gets replaced with, like, 3 close braces. So that gets subbed in during pre-processing. So that's why that works. Can defined statements be modified? You can unset them and then reset them with a different value. You can do that, but could you define a section of code, like print statement for a loop? So doing multi-line, something that you would do in multiple lines of C, it gets cumbersome. Like, it's possible with a defined statement because, because of C's rules about whitespace and how it basically doesn't matter. You could define, like, an entire function inside of a defined statement, but the thing is, at that level, you really should just be using functions, Normally, defined statements are used primarily for small syntactic manipulations, rather than, like, replacing the entirety of functions. Although, we do a little bit more with preprocessor commands at the end of the course, and one of the examples at the end of the course is using defined statements to sort of rewrite a print statement, because you can get them to take arguments as well, which is kind of cool. Let me see. I'll just show you briefly what it looks like. Preprocessor. Yeah, see, you can use these defined statements as if they were like proto functions, but it's like you can, but it makes it a lot harder to debug, because with functions that, like, C knows, it can give you more useful, it'll give you more useful error messages if you're using functions and you're not using defines. Because, like, from the perspective of the C error generation system, that's past the preprocessor, so anything that's going on in the preprocessor, it doesn't care about. It's just looking at the program post-preprocessing. So there you go. If I were to type define hi, printf hello world, and then put hi in your main function, would that work? Yes. Yes, that would work. That would absolutely work. So define hi, printf hello world. There you go. Semicolon and everything. Hi. And of course, one of the advantages of this is that it has the same sort of abstraction. See? Hello world, right there at the top. It has the same kind of abstraction ability as functions and variables in that you can use high as many times as you like throughout the code, right? So I'll just show you. Okay, I want to show you guys one more interesting little tidbit. All right. What if we made a mistake and we put a less than or equals to here rather than a less than? Uh-oh. Look at that. So, does whatever you're defining have to be in all caps, or is it just convention? That's just convention. That's just convention. So, in Python, something like this would be an error. You would get an out array, you would get an indexing exception. I forget what it's called. Index out of bounds exception, something like that. You would get a terminating, like that would be a terminating bug, right? Not so in C, because one of the things that C does not check is that the value that you're reading is even in the array. Ha ha ha. So this is a fun little thing about arrays. We are reading with this loop, and in this execution, you can see... Oh, I should blow that up just a little bit. Let me see if I can blow this up. There you go. So in this guy, you can see we read all of the elements in the array, and then one more is added. One more that contains smelly junk data. Well, 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 well. Basically, by reading... So if the size of the array is n, then the last valid array index is n minus 1. If you read n, you are reading the memory cell that comes immediately after the end of the array. This is why C, this is one of the big reasons C is considered to be an unsafe language. It does not check to make sure that the array that you're reading is as big as the index that you're reading. And you can actually do this quite a lot. So let's see what happens here. We can read quite a long ways into dead space. Right? That's not typically a good thing. And if we read far enough, we'll hit something which, yep, okay. Come on. Daddy wants a seg fault. There we go. Excellent. Segmentation fault. So, you can read past the end of an array. If you read sufficiently far past the end of an array, the way that the operating system works is each process is kind of sandboxed in its own little chunk of memory. And if your program tries to read values outside of that small little chunk of memory, it produces the deadly and dreaded segmentation fault, or seg fault. Seg fault basically means you have tried to access memory that does not belong to you. Segmentation faults, like the speed with which a segmentation fault is produced, is highly dependent on the placement of the array in memory. And since that placement is essentially random, you have an essentially random amount of memory that you could get through before finding the end of it. So you never know how close you are to a seg fault. But this is a common problem if you have something like an infinite loop type situation. It'll often show up if you're infinitely looping over an array, you'll often end up with a seg fault. Which, you know, I just generally wouldn't recommend. So here's an interesting thing as well. And I'm not sure if this will work, but it might. It might. This should make it... this should make it clear to pick out... and I'm just gonna not care about that case. We'll just not care about, like, closing it nicely and putting everything on a different line. Alright. Oh, it does give you some information about macro. Okay, triple close no longer applies as well. Oh, it does tell you what the macro is. That's fun. I didn't know that. Alright. GCC. There we go. Now, we got a seg fault. Let's see if we can find... So the thing I'm looking for is the bar array, and if the bar array is put after the foo array in memory, then we should be able to see it in the memory dump somewhere. We might just be getting unlucky. Yeah. Ha! Oh, no, that's cool. All right. This is fun. So in the memory dump, you see how I was telling you that, like, the memory that you get is like the old memory from old executions? See this great big block of zeros? That's from the previous running of this guy. Right? Actually, it's longer than that, actually. This block of zeros came from a previous execution of the same program. That's this, like, it should have a 6 out front. Or maybe it doesn't. Maybe I'm wrong. That might be wrong. I might be stupid. It might just be zeroed out memory. But yeah. So anyway, that's you can take a look at memory that doesn't belong to you in C, which is kind of interesting. Yeah. Next time we'll talk more about this stuff. That'll be sufficient for today. Those are all very important things to know about. I know we kind of strayed from the slides a bit, but I think we definitely have stuff going on somewhere about seg faults. Might not get to seg faults till we talk about pointers, because it's really easy to make a seg fault when doing pointers. But anyway, are there any questions? Any questions from the audience today? Is the chat still working? Or are you guys just kind of done? Did I completely blow your mind with seg faults and out of bounds array access? Because you guys are a curious lot. I would normally expect like questions about out of bounds array access. My day is only just begun. There. Okay, good. Thank you. Thank you, Andrew. I can confirm that the chat works now, which is good. Yeah. There's no indexing error. That's correct. In order for there to be an indexing error, C would have to check at runtime, actually, that the requested array index is inside of the array. And C does practically zero dynamic checking. So it doesn't really do any checking at all while the program is running. Any checking that it does is up front. It will run into runtime errors where, like, if you try to use a function in a library that has a header file, but, like, the definition of the function doesn't exist, that'll be a runtime error because it's like, cannot find function definition, please provide. But aside from that, it doesn't check that sort of stuff. This is really programming without the safety net. Very much programming without the safety net. Yes, as the class gets smaller, as the semester wears on, which is an inevitability, it's kind of funny. Like, you'd expect, if people have a really busy week, attendance goes down, and then afterwards it should pop back up again. It doesn't ever really. Like, once people, like, I guess once you stop going to class once, there is it's much more likely that you just not go to class for the rest of the semester. All right, thank you very much. See you guys on tomorrow, which is Tuesday. See you guys tomorrow. Take her easy. Are there other ways to print arrays? No. I mean, if you want to write a slightly different algorithm for printing it, like if you want to, change like if you want to print every element on a new line or something like that, then go right ahead. But nah, you just kind of got to loop over it and print every element of it. The alternative to that is using CTutor to be able to actually view inside of the algorithm and, see the memory as it's being added. But yeah, that's... Nope, you got one way of doing that in C. All right, take her easy, folks.